Welcome to our beginner-friendly tutorial on selection control. In this video, we'll delve into the intricacies of selection control, covering everything that you need to know to master this fundamental programming concept. Here's what we will cover: a detailed explanation of simple selection, multiple selection, nested selection, exploring their uses and importance in algorithm. We'll also talk about the introduction to case construct in pseudocode, a powerful tool for handling multiple conditions in a structured manner. We'll also look at the step-by-step guidance on developing algorithm using various forms of selection control structure, with practical examples to reinforce your understanding. And then we'll look at tips and best practices to help you optimize your code and make informed decisions when implementing selection control. Many a times in our everyday life, we come across situations where we need to make certain decisions or take certain actions if a certain condition is true. Let us take, for instance, you walk into a restaurant. You need to consider whether you are hungry or you are thirsty. If you are hungry, you buy food, but if you are thirsty, you buy a drink. Let's assume that you are hungry. You will now decide whether you want to buy rice or you want to buy banku. You see, depending on the condition that you find yourself, you will take one action or the other. This is exactly what we do in programming. Most often, depending on a particular condition, you want your program to take one action or the other. To help you do this, we use what we call relational operators. Relational operators are simply the operators that we were taught in primary school. Less than, greater than, equal to, less than or equal to, greater than or equal to, not equal to. The only difference you may realize is that they are written a bit different from what we were taught in our elementary mathematics. Take note of how they are written here, especially when it comes to the equal to. Notice that it is a double equal sign. A single equal sign means that you want to assign, but if you want to compare two items to make sure that they are the same, then you need to use a double equal sign. Let us look at the example we see on the screen. Assuming that we have two variables, one of them contains a student attendance and the other contains part-time. So we want to compare if what is in student attendance is the same as what is in part-time. If what is in student attendance is the same as what is in part-time, we want to take an action, and the action we want to take is to add one to another variable called part-time count. And so how do you express this in pseudocode? You start with the keyword if, and then the condition that you want to test would follow. Then you bring the keyword then. If it is true, what should you do? Whatever you want it to do should be listed between the then and then the end if. So let us use the example we used earlier. Let us take, for instance, that we want to check if we want to buy food or we want to buy drink. So in that case, we would have said if hungry is equal to yes, then buy food. Or we could say if thirsty is equal to yes, then buy drink. So you see, an action will be taken whether a particular condition is met or not. So if the condition you put here is true, then the action that you want happen should be in between the then and then the end if. Again, look at the structure of how it is written. You start with if, then the condition will follow, then the action will follow, and then you end it with end if. Let us look at another example. In this example, we are going to consider another action to be taken if the condition that we gave is false. So let us take, for instance, let us go back to the example of going into the restaurant. So you go into a restaurant and you want to check whether there is rice. If there is rice, you probably want to buy rice. What if there is no rice? Similarly, when you come into programming, if you want your compiler to take an action, if the condition is false, then you introduce what we call the else statement. So in this example that you see, we want to check the account balance of a customer and see if it is less than $300. If it is less than $300, we want to surcharge the person $5. What if the person's account balance is not less than $300? If it is not less than $300, we probably want our program to take another action. In this instance, we want our program to surcharge the customer $2. And so instead of bringing an end if at the end of your action, if it is true, you do not do that. You bring what we call the else. And then after the else, you bring the set of actions that you want taken if the condition is false. It is only after this that you bring your end if. Let me go over it again. I said, whenever you have two possible actions, you want one action to be taken if the condition is true, and one action to be taken if the condition is false. Then you write your if statement, your condition, the then, and then the actions that you want taken if the condition that you've stipulated above is true. But if the condition is not true, you write your else statement, and then you list the actions that you want taken if the condition is not true. Then, like always, you end your if statement with an end if. Sometimes, to help you select very specific items, you need to combine two logical statements to be able to make a decision. In that case, you use what we call a logical operator. Logical operators help you combine two or more logical statements in order to conclude or come to a decision. Let us look at the example that we have on the screen. We want to check if a student is a part-time student, but we don't only want that. We also want to check if that student is a female. And so the first logical statement is we will check if the student is a part-time student. So you can see we write if attendance is equal to part-time, right? So we have a variable holding the student attendance, and we have a variable holding part-time. And so we want to compare the two. If the student attendance is equal to part-time, then we don't want to just stop at then. We also want to check if the student is a female. In that case, you can use your logical operator to combine. There are two main logical operators. We have the AND logical operator and the OR logical operator. But luckily, these are used just as we will use them in the English language. When you use the AND logical operators, then both statements have to be true for the whole statement to be turned true. This is what I mean. If you use AND, then the student attendance should be part-time, and then the gender should be female before we can consider all of this to be true. So for the action after the then to be taken, both of these statements has to be true if you are using the AND logical statement. But in a situation where you are using the OR set logical statement or the logical operator, then you don't need both logical statements to be true. So in this case, if we use OR, then we only need one of these to be true. Either the student is a part-time student or the student is a female student. Then the action will be taken. If both of them are true, the action will still be taken. The action will only not be taken if both of them are false. So when you use the OR logical operator, remember that it is only when the two logical statements are not true that the action will not be taken. But if you use the AND logical operator, it is only when the two logical statements are true before the action would be taken. You may have both operators in one expression. To avoid getting confused, it is always advised to use brackets or parentheses to separate them. Let's look at the example on the screen. We are supposed to check if record code is the same as 23 or update code is the same as delete and account balance is the same as 0. If all of this check out, then we should delete the customer record. You see that because we are using both operators, it becomes a bit confusing. When you have such a situation, it is easier to handle this by putting parentheses around two of the operands, solving that, and then moving on to the next operator. Let us look at how it looks like here. So you see that we have the parentheses around record code and update code. After we have solved this, then we can now bring the result and pair it with the account balance. What do I mean? Record code is the same as 23 or update code is delete. If we combine these two equations and for instance we get true, then we can now say that if account balance is true, then we are now pairing true, and so that will turn to true, which would give us the opportunity to perform the action after the then statement. There is another operator, another logical operator that I want us to talk about. That is the not operator. The not operator gives the opposite effect of the evaluation of an expression. So for instance, if the record code is 23, then this would have evaluated to true. But if you put the not operator here, then it changes the results from true to false. And so whatever the evaluation of this expression is, this not operator would turn it to false. So if it is false, then the not operator would turn it to true. And what is after the then would be executed. However, if it is true, then the not operator being introduced here would turn it to false. And then whatever we put after the then operator would not be executed. Let us look at something else called a nested if. A nested if is simply putting another if inside an if. Sometimes we may have a lot of options. For instance, we want to go and buy some drink from the restaurant or cafeteria. We go there and we want to check if there is Voltic. If there is Voltic, that's what we prefer. But what if there is no Voltic? Sometimes you want to give your user another option and not just give the user a default option. So you want to tell the user that if there is no Voltic, check if there is Belacqua. If there is no Belacqua, check if there is an Awake. All of these are different brands of water, but you want to be sure that your preferred brand is purchased. And so you check for the first one. If the first one does not exist, you want to check for the second one. If the second one does not exist, you want to check for the third one. It is only after all the options have been exhausted, then you want the user to perform the default action. So let us look at the example that we have. We want our user to check if the record code is A. If the record code is A, an action should be taken. However, if the record code is not A, we don't want our user to just come to the default action, which is what? Increase the error counter. We want the user to check. So we put another if after the else and say that if this option is not available, check if the record code is B. If the record code is B, we want to perform this action. It is only when the record code is not B that we would come and check to see if the record code is C. However, If we exhaust all of these three options, then we want the action taken to be increasing the error counter. So you see that in this case, we have different options, and all of these options are checked before the last option is given. And so when you have a situation like this is how to handle it. You put another if after the else to help you be able to check. Also, one thing I want you to take note is that all the ifs that were introduced were closed. So that's why you have an end if here, which is closing this particular if, and then an end if here, which is closing the second if, and then an end if here, which is closing the very first if that we wrote. However, sometimes when we want to make very specific selection, we can put an if after an expression has been evaluated to be true. Let us look at the example that we have on the screen. We want to check if the student is a part-time student. However, after we have found out that the student is a part-time student, then now we want to check and make sure that this student is a female student. And so you can see that the first expression is that if student is equal to part-time, when this is true, then we can come and check if student gender is female. When this is also true, we also want to drill down further and check if the student age is greater than 21. It is only after these three checks that we want to take an action. So this is also allowed, a situation where you put an if inside a true statement, and this is what we refer to as a non-linear if statement. When you have a non-linear if statement where if the expression evaluates to true, you want to put another if inside, you could actually make use of the logical operators that we talked about, the AND and the OR logical operator, to combine all of these ifs to give you the same or a similar effect. Let us look at the example that we have on the screen. We want to design an algorithm that will prompt a terminal operator for 3 characters, accept those characters as input, sort them into ascending sequence, and output them to the screen. If you look at the question above, let us identify what our inputs are. From the question, we can see that our inputs are 3 characters because we expect the user to give us 3 characters. What will be our outputs? We are expected to give out 3 characters at the end of the day. So our output will be 3 characters. Then we now come to what have we been asked to do? We've been asked to prompt the user. We've been asked to accept the characters that the user provide. And we've been asked to sort and then give out the characters in ascending sequence. So we would have a table that looks like this. This is how our definition table is going to look like. So the main thing that we know how to prompt, we know how to accept, we know how to output. What we now need to think about is how do we sort? So for instance, let's assume that we have 3 caps, right? One of the caps contains the letter C, another cap contains letter A, and then the third cap contains letter B. Now we want to sort them in ascending sequence. One thing that we should note is that variables can only hold one character or one value at a time, meaning that if we take letter A and come and put it in the first cap, whatever is in the first cap disappears forever, and so we loses it. So what do? We'll find an empty cap. Take what is in the first cap, which is C, put it into the empty cap. Take what is in the second cap, which is A, put it into the first cap, and then take what we put in the empty cap, which is C, back into the second cap. So now you would have realized that we would have successfully pushed A into the first cap. We can perform a similar operation between the second cap and the third cap to bring B to the second cap and C into the third cap. By the end of the day, you would realize that we would have successfully sorted these characters in ascending sequence. So how do we express this in programming? So on line 1, we prompt the user for character 1, character 2, and then character 3. Then on line 2, we receive what the user has provided into the variables char1, char2, and char3. Then on line 3, we want to check what is in character 1 and character 2. If what is in character 1 is bigger than what is in character 2, then it means that we need to swap. So we created another variable, which is temp. Remember the illustration we did earlier? We said we would have an empty cap. So that is what we have created here as temp. And then we will take what is in the first cap, put it into the empty cap, and then put what is in the second cap into the first cap, and then put what we kept in the empty cap back into the second cap. So you see that when we continue to repeat this a number of times, we would sort our characters in ascending sequence, and then on line 6, we can successfully print out these characters. Remember, we said after writing your algorithm, you can take a set of data to test your algorithm. And so we can use this set of data to go through our algorithm, check to make sure that we have a successful algorithm. So this is our check. And at the end of the day, we realize that whatever algorithm we wrote has successfully solved it. In this example, we are being asked to write a program that will require us to read a customer's name, purchase amount, and a tax code. The tax code has been validated and will be one of the following. If it is 0, then it's a baby need, so we don't tax it. If it is 1, then it's vegetable and food. We put 3% tax on it. If it is 2, it is drinks. We put 5% tax on it. And if it is 3, it's a special sales, so we put 7% on it. The program must compute the sales tax and the total amount due, and print the customer's name, the purchase amount, sales tax, and then the amount due. Can you pause here and see if you can solve this on your own? Whilst you solve it, take time also to like this channel, click on the bell icon so that anytime there is an update, you would be notified. At the end of the day, you should have a definition table that looks like this and a solution that looks like that. If you are able to solve it on your own, congratulations. We are making progress, and very soon we'll be writing very sophisticated programs. Thank you very much for joining me today. I hope to see you another time. Have a wonderful day.